In this video, I'll be covering question 3, part D from the 2023 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see my other solutions, please check out my other videos. Alright, I'm going to start video D the same way I started A, B, and C in case you didn't watch those. But I will tell you this, when you hit an AP Calc question that looks like it's a whole page, like you flip the page and you're like, oh man, I can't believe how much I see in front of me. You got to pause for a moment and take a deep breath. I guarantee you that the problem itself is probably not nearly as difficult as your brain is making it think it is, because you're just not used to seeing a full page of an AP Calc question. I'm not used to it. So when it happens, like, it can be overwhelming, and I really just recommend like pausing and taking a moment before you dive into this. So once you've taken your breath, now come back at it. So we're looking at D right now. D is telling us using the separation of variables, so it's telling us exactly what to do. They want us to find an expression for m of t, the particular solution, which particular solution, when they say that, is telling us that we're going to find our plus c value. When you're taking an antiderivative, right, you always get out those plus c's, and so when they want the particular solution, they're telling you to go find that plus c value. So we're finding the particular solution to this differential equation, so to this derivative right here, and then they're giving us this initial value that's on there, and that initial value, that's the value we use to find out what our plus c value actually is. So, first things first, let's go do what they're telling us to do, which is use separation of variables. A couple of years ago, they never used to say this on the test. Now they're at least telling us what they want us to do. So, the first part of this is we want to take this derivative here, this differential equation, and separate it out. We want the m pieces on one side and the t pieces on the other. So I will go ahead, and the first thing I'll do on this left side is go ahead and multiply both sides by dt to get that out of there. And then I want to move the m piece over. So that m's on top, I'm going to divide or multiply by 1 over 40 minus m on both sides. So 1 over 40 minus m. Now we'll just clean this thing up and see where we're left. So on this left-hand side, I've got 1 over 40 minus m. The dt's cancel. I've still got my dm over there, equals 1/4. My 40 minus m's are now going to cancel. And then I've got dt on this side. So we've now done the first part of the process, which is separate out the variables to the m side and to the t side. Now what you're essentially looking at is you are looking at two separate integral problems. And we just need to solve both of these like they're their own individual problem, and then bring them back together at the end. Looking at the left side first, what you should be doing there, if you can get yourself to sort of understand that whenever you've got a variable plus a constant, that really, as far as integrals are going to be concerned, is always going to, you can always kind of think about that as the variable, as the full chunk. And what I mean by that is, if you can look at this problem right now and kind of think about this as being 1 over x, then it's real quick to get to the fact that that's your special case for the natural log. So if you can look at that and see that that's 1 over 40 minus m, and this only works when it's a constant plus or minus your variable. If there was multiplication or m squareds going on, that'd be different. But when we get this constant plus or minus, this is going to end up getting us out just the same sort of thing as just having an x right there. That's next level stuff, but I want to present it to you in case you're ready to take on some next level stuff that can save you some time. Otherwise, we've got to come back and we have to treat this like a U substitution problem. So looking at that left side, the first thing we want to do, step one of a U substitution, is we would choose the U. When I go looking for my u, I have a priority list that I work my way through. The first thing I go looking for, if it's available to me, is a natural log. If the natural log's not there, then I go looking for what I call the inside piece. A function inside another function. Think about it like a chain rule problem. Whatever was inside a set of parentheses or inside another function. And if that's not there, the third thing I go looking for is the bottom of a fraction. Looking at our integral on the left side here, I start at the top of the list. I don't have a natural log, so I'm not going to use that. I don't have an inside piece. Well, I've kept those parentheses around. That's technically not an inside piece. I could drop them and be just fine. What I'm looking at on this one is my third option here, the bottom of a fraction. I'll choose my u now. U is going to be 40 minus m. Step 2 of the process when we're taking the u substitution is we now need to find the derivative of that. So this would be du dm, and you always want to use that derivative notation, that differential notation. Du dm, du dx. Looking at the right-hand side here, the derivative of 40 would have been a constant. That goes away. And then the derivative of negative m would be negative 1. Step 3 of the process is now always the same. What we want to do is we need to solve for this dm here. We need to change that starting integral to talk entirely the language of u, and that means changing out that dm for a du. So you're going to go to your derivative and you're going to solve this like a normal algebra problem to get dm by itself. I'll multiply both sides by dm to get it out of the bottom. I get du equals negative 1 dm, and then you would go ahead and divide by negative 1, divide by negative 1, and we end up with du over negative 1 equals dm. Now that we've done that, we're going to take that and substitute it in for the dm. We're going to take our u and substitute it in right here. Working our way through this now, left to right, it's either one of the pieces you substitute in for, or it gets left alone. We've got the integral of 1 over, and now all that stuff on the bottom is going to be u. And then instead of dm, I now have du over negative 1. This is what I call your reward for all of your hard work, a brand new math problem. Ideally, what we've done now is turn this into something that we do know how to take the antiderivative of. What I'll do to kind of make it more obvious is I'm just going to multiply this negative 1 up into the front. So that would put a negative 1 on top over u du. Now what we're looking at is this special case antiderivative that I was mentioning earlier. I call them special cases because they're ones you just have to have memorized. If you don't have it memorized, you're not going to guess it. This is our special case for natural log. Taking that and applying it here, we end up with the negative natural log of the absolute value of u. Normally, we always put a plus c on the end of these things, but because we've got a whole other integral over here to take that's also going to have a plus c, we just want a singular plus c for the whole problem, and I always keep my plus c on the right-hand equation. It will make the algebra a bunch easier. That means we don't need our plus c's. We get to skip that step. And then the last step of a u substitution problem is you remind yourself you didn't really care about u, you cared about what u was, and so you're going to plug that u back in. That would make this the natural log of the absolute value of 40 minus m. Now we've taken care of our left-hand derivative, and we come back and we need to take care of our right-hand derivative. Looking at this right-hand derivative now, it's a heck of a lot easier, right? The antiderivative of a constant is just going to be 1/4, and then it gains a letter back, plus c. Now we just take that and drop that all the way down here, 1/4 t plus c. So we've now taken our antiderivatives, and they're set equal to each other. It's at this point that we come through and use that initial condition that they gave us. This m of 0, if I could write it cleanly, m of 0 equals 5. What that's saying to us is when we plug in our t as 0, we want the m value, the answer to all of that, to equal 5. We'll come and plug our pieces in. We get negative natural log, the absolute value of 40 minus plugging in 5 for m now, is equal to 1/4 plugging in 0 for t plus c. Doing that algebra real fast, and we end up with the negative natural log of the absolute value of 35 equals, that stuff zeroes out, and that all equals c. We now have our constant, and what we do is we're going to take and plug it in to our equation up above here. So next part of our process, we're going to take and we're going to plug that in. So we're going to start on the left-hand side here, and we've got negative natural log of the absolute value of 40 minus m is going to equal 1/4 t, and then plug in for c minus the natural log of the absolute value of 35. And then we just keep rolling with this now, and we need to solve to get m by itself. So the final answer, the particular solution, remember, is going to be an m of t equation. So we need to get m by itself. First things first is you need to isolate the natural log on the left-hand side, that piece that has the m in it. All we need to do right now is just go ahead and divide everybody by -1. Out of there, we're going to get the natural log of the absolute value of 40 minus m is going to equal 1/4 divided by -1 gets us -1/4 t. The negative on the next piece is going to get us plus the natural log of the absolute value of 35. From there, to cancel out a natural log, you're going to raise e to that power. So e to that power equals e to that power. Remember, e and natural log are inverses of each other. When I go e to a natural log, the e and the natural log cancel out, and whatever is inside that parenthesis is going to drop straight down. So on this left side here, e and natural log cancel out. That's going to drop us down our 40 minus m, and we can go ahead and drop those absolute value bars. And now on the right-hand side, we'll have e to the -1/4 t plus the natural log of 35. When we continue to solve this, the next move here is going to be a law of exponents move. Whenever you've got this power right here with a plus going on, that came from two things being multiplied. Remember your laws of exponents, if I have like bases, so x to the 5th times x to the 3rd, I add those exponents. That's really x to the 5 plus 3. Oftentimes you do it so quick that you forget that that's what's going on. So what we have here is really two things that had been multiplied. And to solve this out, we need to break it back up into those two things being multiplied. This would be e to the -1/4 t times e to the natural log of 35. We break that addition of our exponents into the bases being multiplied. What that can do now is, we're going to take advantage of this e and natural log can cancel each other out to cancel this piece out on that side. That'll give us 40 minus m equals e to the -1/4 t times 35. We're running low on room, so we're going to move ourselves up over to the side here. And as we do, the first thing I'm going to do is just rearrange that piece to make more sense. I'm going to put the 35 in front, but it's on the other side of the equals. So this would be 40 minus m equals 35 e to the -1/4 t. And we're trying to get m by itself now, and it's just going to be a couple of more moves. We'll move the 40 over from this side, so minus 40 minus 40. You get -m equals 35 e to the -1/4 t minus 40. And then our last move here is we're just going to divide everything by that -1. Divide by -1, and we get m equals 35 divided by -1 gets us -35 e to the -1/4 t, and then that would end up being negative, so plus 40. That's our final answer. They wanted it as an m of t equation, so I might, just to make sure they don't ticky-tacky with me on the final point here, I might just call it m of t, although I think they would probably accept both of those. And that's going to be our final answer there. So this whole thing would have been 4 points in total. We would have gotten 1 point out from doing our separation of variables and setting that piece up. So just getting to that point would have been 1 point there. Finding our antiderivatives, that would have been 1 point here. Finding that constant of integration, that would have been 1 point here. And then from there, plugging that constant in and getting all the way to the end would have been a 4th point. So this whole thing would have been 4 points when all was said and done. The key with this really was, I think, the This move here, where you've got to remind yourself about how if you had like bases, you were adding exponents, and you're really undoing that work to get back to two things being multiplied. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.